Bismillah. Bismillahirrahmanirrahim. Assalamualaikum and good afternoon to all. My name is Abdul Shafi. I'm from University Malaysia Police, and this is uh, the presentation for the 5th International Symposium on Intelligent Manufacturing and Mechatronic Engineering, SIMM 2023. And my project is about classification of Malodor gases in greenhouse environment using artificial intelligence technique. So for this presentation, first we talk about introduction, and then the methodology of the project, the result, and the last one is the conclusion. So as we all know and we aware of this, uh, one of the important issues in this era is about air pollution. Air pollution can cause a lot of problems in our health, as well as the depletion in the ozone layers. This will result in the greenhouse effect where the temperature in the Earth's surface will become higher and it's become difficult for us to breathe. So one of the factors that contribute to the air pollution is the Malodor gases. Okay, so that we can use the technologies. Nowadays, we can use a lot of technologies such as sensors, such as there are many sensors available in the market to detect the specific sensors, a specific gas, and we can use the artificial intelligence technique to classify them autonomously. So during the literature review process, we found out that there are many existing methods on analyzing air quality. These include gas chromatography, chemical sensors, as well as the electronic nose. So most of these devices, they are using methods of differential gas concentration. And if they see that the current values exceed the threshold, then they will give values. They will give notification. Then most of the data will fed to the machine learning algorithm so that they can classify what types of the concentration of the gas and its own class of gas. So the method has been proven reliable and it offers optimum solution within short computational times. So we have actually developed one system that comprised of four types of sensors, and all of these sensors they are connected to the Arduino Uno, and Arduino Uno is connected to the laptop for the data visualization. First, there are sensors of DHT11 where this is used to measure temperature and humidity. Then we have a MQ135 that is used for the carbon dioxide sensor. And then MQ7 is used to detect ammonia gas, and MQ4 is used to detect the methane gas. So overall, we have three specific sensors and one sensor for temperature and humidity. For the data collection process, first we divide the classification or the class level into three types of condition, which is first as normal air, as we are in today, and the second one is the rotten chicken, where we put rotten chicken inside the case of the sensor, and then we want to capture the gases that produced by the rotten chicken. And then the third one is the motor vehicle exhaust gas, where we collected the gas coming out from the exhaust of a car. So for this condition, for overall of this condition, we record the data for 3 hours. Means that the data is sent for every 10 seconds, which result in the 1080 rows of data for every condition. So the data is then fed to the PCA, which is a principal component analysis, where we want to use a PCA to first to reduce the dimensionality before being fed to the machine learning classifiers. This is because we hypothesize that using a PCA, we can reduce the dimensionality of the data first. So it makes easy for the machine learning classifier to capture the important things of parameters inside the gas, and then classify it. So based on the PCA result, you can see that in the figure here we have three type of graph, which is the first one where we took data from the first hour interval, and then the second one is we took the data for the second hour interval, and the last one C is when we have a third hour interval. So you can see that A, B, and C. A is for the normal gas, B is for the rotten chicken, and C blue line is for the motor vehicle from gas. And we can see that for the third hour interval, we have quite distinguished variable inside with this figure, where it has been reduced the dimensionality, and then it has been clustered to its own group. And this is the result for the classification process. We use three type of machine learning classifier, which is neural network, decision tree, and support vector machine. And all of this algorithm, it is being realized using a Weka platform. So the Weka, we put all the data inside the platform, and it comes with this result. And we can see that SVM has the higher accuracy result, which is 79%, followed by neural network and decision tree. And there are about 1,519 uh, rows of data has been classified as true positive. Meanwhile, 413 data has been classified as the uh, negative. So for the precision, we got all of this method 100%, and the recall is SVM has the highest value as well as F1 score. So as for the conclusion, this simple sensing system has been successfully done to sense the appearance of the Malodor gases. And we can see that SVM has the most accurate and better performance than other machine learning methods. And also, along the way, we can see that the PCA, principal component analysis, it can be used to classify the presence of methane, ammonia, and carbon dioxide. But to be able to do it autonomously, we need a machine learning classifiers. While PCA is just about the reducing the dimensionality and cluster the gases into uh, its own respective class. So the machine learning can have a higher accuracy or higher capability to distinguish it better. So thank you. That is all for my project. And if you have any question, put the question into the comment. Thank you so much.